Okay, last thing we're going to talk about with these inequalities, and then we'll just get ready for your test, which will be Friday, is solving compound inequalities. So solving them, not just graphing them, but solving them and then graphing them as well. Okay, so these are our ands and ors, but we have to do a little solving before we get to our solution. So for example, we might see something like this. This says 2x plus 1 is greater than 3, or x minus 2 is less than or equal to negative 5. This is an or statement, and we know it's an or statement because it has the word or in it. And our rule of thumb from yesterday, we expect this to have kind of two arrows running away from each other. So what we're going to do with this or statement is we're going to solve both pieces of this separately and then put it on the number line. So to solve, I would over here subtract 1. That gives me 2x is greater than 2, and I'll divide by 2. I get x is greater than 1. Or, I'm going to solve the other piece of this. I'll add 2 to both sides. I get x is less than or equal to negative 3. So on the number line, what I have is my two boundary values. There's 1, there's negative 3. Make sure you put them in the right order. Smaller number to the left, bigger number to the right. Let's see, x is greater than 1 goes this way. Or x is less than or equal to, with a closed circle, negative 3, going this way. Okay, so separate them, solve them, put them on the number line. And again, with an or statement, we expect it to go out in two different directions. Anything that's covered by that, by our shading is part of the solution set. Anything that's not covered by the shading is not part of the solution set. So there's an example of an or statement. You just solve it, you graph it. This one is an and statement, and we know this is an and statement because it says the word and. Sometimes they look like that, sometimes they don't. With and statements, this one happens to look like it. We're just going to solve this separately. So I would add 4 to both sides over here. I get x is less than 11. Now I'm not going to put that on my number line yet because I don't know what the other boundary value is. So let me find that out so I can put them in order. So over on the other one, I would add 9. And get 2x is greater than 10, then divide by the 2, I get x is greater than 5. So my two boundary values are 11 and 5. Now I'm going to graph these separately, and we're going to look at them carefully here. Look at our solution. Less than 11 would go all the way this way to the left, and greater than 5 would go all the way this way to the right. We got to think about what we talked about yesterday. It has to be, our solution set is the numbers that are both of those things at the same time. So the overlap kind of this region would be my solution set. What I want you to do is make sure it's clear to me what the answer is. So I'm going to go down on the second number line. I graphed kind of sloppy on the first one to find my solution set, but it should be clear to me what the final solution set is. Should look like that. Okay, so that's an and statement. This one is also an and statement. We know it's an and statement because it doesn't say the word or. If it doesn't say or, it's necessarily an and statement. This one's a little different though. This is one of those squished together and statements. So what we need to do is pull it apart before we solve. And this is where students get a little messed up, and I want you to make sure you're clear on this. Okay, we're going to rewrite this as 4 is less than or equal to 2x minus 8, and 2x minus 8 is at the same time less than 16. So be really careful here. It's not that the 2x belongs to the 4 and the minus 8 belongs to the 16. That's not how that works. The entire middle belongs to both endpoints. It's like if you have a peanut butter sandwich and you pull apart that bread, the middle, that peanut butter, is stuck to both pieces of the bread. The 4 and the 16, that's like your bread. The 2x minus 8 is like the peanut butter. It's stuck to each of the endpoints. Now that we have that, we can solve. So I would add 8, add 8. 12 is less than or equal to 2x. And I would divide by the 2. I get 6 is less than or equal to x. And at the same time, I'll do the same thing on this side. 2x is less than, that's 24, divide by 2, x is less than 12. So now what I want to do, because this is an and statement, and remember our and statement we expect to look like that, right? The little line segment connected. I want to squish that back together. So in order, I have 6 and I have 12. The x is in the middle, and I want to make sure I pay attention to those inequalities. So let's see, x is greater than or equal to 6. So this should have a greater than or equal to, which is less than 12. And again, reading that now left to right, 6 is less than or equal to x, which is less than 12. And what we practiced yesterday is putting that on the number line. Boundary value of 6 and a boundary value of 12. We have an open circle and a closed circle, and we connect them. Okay, so and statements can say the word and, or they cannot say the word and. We know, however, again, if it doesn't use the word or, it will be an and statement, and you should expect that little line segment connected together. So here are 3 problems, and I see 1 or and 2 ands. This one's an and, this one, because it doesn't say or, also an and. Okay, and I would solve them separately. Add 7, I get x is greater than 16. Add 1, or x is less than 4. Putting that on my number line, I find 16, I find 4, open circle arrow that way, or x is less than 4, open circle arrow that way. There's my or statement, right? My general rule of thumb. I got 2 arrows going to the left and the right. For the next problem, for this and statement, I would subtract 2. I'd get x is less than 3. And at the same time, adding 3, x is greater than negative 3. So on my number line, I expect it to go, let's see, between negative 3 and 3. So greater than negative 3 and less than 3. So like that. This third problem I have, I'm going to pull this apart. 14 is greater than x plus 7, and x plus 7 is greater than or equal to 0. I would subtract 7 from both sides, and here I would get 7 is greater than x, subtract 7, and x is greater than or equal to negative 7. So as I put those on the number line, I want to make sure, again, I put them in order. Negative 7 to the left and 7 to the right, and I expect those to be connected. I should have a closed circle to an open circle. Okay, so that's it. Compound inequalities. We solve them separately. When an and statement is written all as one thing, we pull it apart and then try to put it back together. And I could write that just as a reminder. Negative 7 is less than or equal to x, which is less than 7. Okay, so we're just going to practice these compound inequalities. There's a Delta Math assignment test Friday, so we'll just review in Zoom tomorrow and on Thursday, and be ready for a test on Friday. All right, have a terrific Tuesday, everybody. Bye-bye.